of solving compound inequalities, first thing we need to do is we need to refer what an and or an or is, or talk about what an and or an or inequality is. The difference between the and or graphs, if you have this graph on the left here, x is greater than or equal to -4 and x is less than 3, this is what we call an and graph. Okay, both x has to be greater than or equal to -4 and it has to be less than 3. All solutions that are greater than or equal to -4 and less than 3 are actual solutions that are highlighted by the shading here. Remember, it's open circle if we don't have the equal to piece. It's closed circle when you do, meaning -4 is a solution. Okay, and graphs you can actually write in a compound format. So if I were to put the numbers numerically, -4 and 3, and then literally x is in between those numbers. All the solutions for x are in between here. Okay, notice my arrow is opening, or the inequality symbol is opening, the open end, like there you go, is towards x when you're dealing with the -4. Therefore, it'll be towards x when you write it up here. And open ends towards 3 when you're dealing with the 3, so it's towards 3 there. So this is kind of a compound way of writing your inequality. So -4 is less than or equal to x, which is less than 3. Now an or type of graph, actually, you have the arrows pointing away from each other, whereas in the and graph, your arrows pointed at each other, here and here. They pointed towards each other. In the or graph, when you write it, they point away. This is an or. Only one of these things has to be true for it to be a solution. Either x has to be less than -4 or it has to be greater than or equal to 3. In fact, there isn't a number that is less than -4 and greater than or equal to 3. So it has to be an or situation. Okay? Or graphs cannot be written in this format. Only and graphs can. All right. So let's go ahead and try graphing some of these. First one here, notice sometimes your inequalities look a little different. In this case, you have 3 parts. You have a left, a middle, and a right. And this would be an and graph because it's written in this format. And we can double check that when we're done. But if I were to subtract 9 from the middle to get n alone, I'd subtract 9 from the left and from the right as well. So it's kind of just like solving an equation, but you're doing it to all 3 parts. So that's 0, I have n, I bring down the inequality symbol, I have -10, bring down the inequality, and I have 8. So notice if I were to graph this, it's sometimes a little more difficult to graph when you're in the compound format, or it feels like it. So what I'm going to do is I'm just going to rewrite it. I'm going to rewrite this part. So n, it's opening up towards n, -10, and this part, n less than 8. So opening up towards -10, meaning my arrow points to the right, so I shade to the right. So I'm just going to put a little arrow right above the -10 saying I'm going to shade to the right. Opening up toward, or on the 8, it's opening up towards n, so towards the left, so I'm going to shade to the left. Notice the arrows are pointing at each other, so I shade in between. Okay. Now, if you recognize ahead of time this is an and graph, you could just set it up and shade like that. But another way to just double check it is to write it in that format. So most teachers will accept this format or this format. You got to find out what your teacher would like you to do. I'm going to go ahead and switch colors for this next one. All right, so the next one here, I have -3, and I'm going to rewrite it just so I have a little more room. P over 2, 0. Okay, so I have 3 parts again. Then I'm going to multiply the middle. Since they're dividing by 2, I'm going to multiply it by 2, which means I have to multiply the left by 2 and the right by 2. All 3 parts. So 2 times -3 is -6. P divided by 2 times 2, they just cancel. And 2 times 0 is 0. So graphing it, -6, 0, close circle on -6, open on 0. And if I were to rewrite it, it would be P is greater than or equal to -6, and P is less than 0. Okay, so I'm shading that direction, and there it is. All right, and the last one on this page, notice this one actually physically says and in between. So the important thing on this solving this inequality, these inequalities, is they are two separate inequalities. So when I look at this first one and I subtract 8, I'm only subtracting 8 with the 64. I don't move over to this side. I don't move over to that inequality. Don't move over to this one. Okay, because it's all by itself over there. So when I do this, I get 8x. That's 0. -72. Divide by 8. 1x is -9. And then we try our other one here. We will add 7. -8x greater than or equal to -72. Divide by -8. Ooh, dividing by a negative. Well, when you divide by a negative, you got to flip that symbol, that sign over. So it went from greater to less now, and you get 9. Okay, so x is less than or equal to -9, and x is greater than or equal to 9. Or excuse me, x is greater than or equal to -9, excuse me, and x is less than or equal to 9. So shading in between there. Now if you wanted to write it as a compound, you could put the x in the middle. You could write the numbers in numerical order, and then the arrow's opening up towards x with -9. It's opening up towards 9 with the 9, and there we've got it. The x literally is between -9 and 9. All right. Let's try one more and situation. We're going to subtract 6. So we get -56, 7k, and -14. Divide by 7. -8, k, -2. Graph, hopefully you've noticed they're always pointing to the left there. -8, -2, open, open, shaded between. All right, now we're going to go ahead and try an OR. So an OR is kind of like that and on the previous page. Whatever I do in this first part only affects this first equation. So subtract 5. I don't deal with the r divided by 9 is less than 0 at all yet. So I get r and 7. And now I can go over and I can deal with this. I'm going to multiply by 9. So another way of showing this, I could just show I'm going to multiply everything by 9. That by 9 and that by 9. It's like multiplying each part by 9. It gives me r, and 9 times 0 is 0. So nothing changes on this side when I multiply by 9. Okay, but really all you've done is multiply this by 9 and that by 9. Okay, so this is an OR. So we have to put the word OR in between. Okay, and so now we're going to graph it. Make sure, notice how the 0, like if I was to put this on a number line, 0 is here and 7 is here. So make sure you recognize, look, my smaller value is listed up here on the right, and it goes here. And this bigger value is listed on the left, and it goes over here. So sometimes it's difficult. We may make a mistake graphing if they're not lined up correctly. Like over here, the -2 and -8, they're numeric order. These aren't in numeric order up here in the statement. So if that's confusing to you, just rewrite it. in numeric order. 0 comes first, 7 comes after that. So in this case, we'd have an open circle on 0, closed circle on 7, and it's shading to the right, and the arrow's pointing to the left. And that, remember, that always works if the variable's on the comes first. The arrow will always point in the direction you're shading. So there we go, and there we go. That means like 5 wouldn't work. 5 is not greater than 7, and 5 is not less than 0. So there we go. All right, now let's go ahead and do this next one. This one's separated, so subtract 3, negative 10p, or negative 10b, excuse me, is less than or equal to negative 40. Notice we're dividing by negative here, and that's going to switch our sign over. So we get b is greater than or equal to 4. Okay? And we have, actually or. Now we can add 10 to both sides, add 10, and 3b is less than or equal to negative 15, divide by 3, and divide by 3, 1b, b, negative 5. Okay, so once again, in this case, it's out of order. 4 actually comes after negative 5, so I'm going to rewrite it. I'm going to write b is less than or equal to negative 5, or b is greater than or equal to 4. Okay, so if I were to graph it, I'd have negative 5, I'd have 4, I'd have a closed circle shading to the right, closed circle shading to the left, and looks like it's a typical OR graph. All right, there we go. Okay, I thought I had put one other on there, so I'm going to try to make this one up as I go. So let's say I have r plus 5 is less than or equal to negative 12. Okay, so r plus 5 is less than or equal to negative 12, and or r divided by 50 is greater than or equal to negative 2. Okay, so if I were to solve these, I get minus 5 and minus 5, and r is less than or equal to negative 17, or, and let's see, times 50, and times 50. So we get r, those cancel, greater than or equal to negative 100. Put them numerically, so I'd have r is greater than or equal to negative 100, or r, r is less than or equal to negative 17. And then graphing. Okay, so here's where it gets weird. I have negative 100, close circle. I have negative 17, close circle. I have shading to the right, and I have shading to the, shading to the left, and shading to the right. Now, in this case, I'm pointing at each other like it's an and, however, it says or. That really means any value for r is greater than a negative 100, any value that's bigger than negative 100, including negative 17 and beyond. So like 0's over here somewhere, including 0. 0's greater than negative 100. That could be a solution. Or, starting at negative 17, any value smaller than negative 17. So that would include negative 100. Negative 100 smaller than negative 17. Negative 200, for that matter, smaller than negative 17. Notice in this OR situation, this is all real numbers. Any real number will work for a value of r here. No matter what you put in for r, you're going to get a true statement because everything gets shaded at the end. So that's kind of a special case here if you want to think of a special case. All right. Good lucky.